It happens at 9:41 in the morning. Not metaphorically, not approximately. Researchers who have studied the geological record at the Chicxulub impact site in the Yucatan Peninsula of Mexico have calculated to within minutes. When the asteroid struck, and what happens in the first 60 seconds after that moment is so extreme, so total, so unlike anything that has happened in the 66 million years since, that it is almost impossible to hold in your mind as a real event. But it was real, and this is what it actually looked like. The asteroid is roughly 12 kilometers wide. That is larger than Mount Everest is tall. It is traveling at approximately 20 kilometers per second, 72,000 kilometers per hour, when it enters Earth's atmosphere. It does not slow down meaningfully. The atmosphere is essentially nothing to an object this size moving at this speed. From the moment it touches the upper atmosphere to the moment it hits the ground takes roughly 1 second. 1 second. In that 1 second, the asteroid compresses the air in front of it so violently that the air itself heats to temperatures hotter than the surface of the sun. Before the rock even touches the ground, the heat pulse radiating outward from the compression wave is already incinerating everything within hundreds of kilometers. Then it hits. The impact site is shallow ocean, the Gulf of Mexico, about 30 meters deep at that location. This matters enormously. A deep ocean impact would have absorbed more energy. A shallow ocean impact means the asteroid strikes what is essentially solid rock beneath a thin skin of water. The energy released in the first second of impact is equivalent to roughly 10 billion Hiroshima bombs detonating simultaneously. Not over days, not over hours. In 1 second, the crater that forms is 180 kilometers wide and 30 kilometers deep. It forms in approximately 90 seconds. The rock at the bottom of the crater, which was solid in cold moments before, is now liquid. The surrounding seafloor for hundreds of kilometers in every direction has been vaporized. Robert DePalma, a paleontologist at the University of Manchester, has spent years excavating a site in North Dakota called Tanis, a site that preserves in extraordinary detail the events of the first hours after the impact. His research, published in the Proceedings of the National Academy of Sciences, revealed something that should not be possible. Fish fossilized mid-breath with impact debris, tiny glass spherules called tektites, formed when vaporized rock was blasted into the atmosphere and rained back down as molten droplets, lodged in their gills. These fish died within the first hour of the impact. 66 million years later, DePalma could see exactly how. What is happening globally in these first minutes? The impact sends a shock wave through the Earth's crust that travels at the speed of sound through rock, roughly 5 kilometers per second. Within minutes of the impact, every major fault line on Earth is triggered simultaneously. Earthquakes of magnitude 10 or higher, the largest possible on the scale, are occurring across every continent at the same time. These are not aftershocks. They're the direct mechanical response of the entire planet to a single blow. In the oceans, the displacement of water by the impact generates tsunamis. Not ordinary tsunamis. Waves hundreds of meters high moving outward in every direction from the Yucatan at the speed of a jet aircraft. Within the first hour, these waves are hitting coastlines thousands of kilometers away. The inland seas of North America are sloshing violently, which is exactly what DePalma found at Tanis in North Dakota, more than 3,000 kilometers from the impact site. The fish were killed not by heat, but by a surge of water driven by seismic activity in the first minutes after the strike. Meanwhile, in the sky directly above the impact site, something unprecedented is happening. The asteroid has punched a hole through the atmosphere. The rock and water and sediment vaporized by the impact, trillions of tons of it, has been blasted upward at escape velocity. Some of it leaves the atmosphere entirely and enters orbit. Some of it goes into suborbital trajectories, arcing across the entire planet and re-entering the atmosphere thousands of kilometers away. As this material re-enters, it heats through friction, just as the asteroid itself did. The sky, globally, begins to glow. This is the heat pulse. Within approximately 30 to 40 minutes of the impact, researchers estimate that the thermal radiation raining down from the sky of re-entering debris is equivalent to roughly 10 times the energy output of a conventional oven globally simultaneously. Not at the impact site. Everywhere on Earth with a clear line of sight to the sky. Forests begin to ignite spontaneously, not from fires spreading from one tree to another, from radiant heat falling from above, as if the sky itself has become an oven. Toon, an atmospheric scientist at the University of Colorado, has modeled the global effects of the Chicxulub impact in extensive detail. His research indicates that within the first hour, wildfires are burning on every continent. The smoke and soot from these fires, combined with the sulfur dioxide released from the vaporized rock of the impact site, the Yucatan is rich in sulfate minerals, begins entering the upper atmosphere in quantities large enough to affect the entire planet's climate. But that comes later. In the first minutes, what is most striking is the silence. At the impact site, there is no silence. There is sound beyond the capacity of human hearing to process, a pressure wave that ruptures rock and vaporizes ocean. But for the dinosaurs standing in a forest in what is now Montana, or wading through a swamp in what is now China, or grazing on a coastal plain in what is now Europe, the first thing they experience is not sound. It is light, a flash, brighter than anything that has ever existed in the sky during their lifetimes, brighter than the sun, coming from the direction of the horizon in the south and west, depending on their location on the globe. Many animals would have looked toward it instinctively. Then, depending on their distance from the impact, the sound arrives. For animals within a few thousand kilometers, the sound wave arrives within minutes, a pressure pulse powerful enough to rupture lungs and collapse eardrums. For animals further away, it arrives later, diminished but still catastrophic. And then, for many of them, nothing else happens immediately. The sky is strange. There's an odd glow. The ground has trembled in ways it has never trembled before. But the dinosaur standing in a Montana forest in the first 10 minutes after the impact does not know it is dying. The mechanism of its extinction is invisible to it, a chain of atmospheric and climatic consequences that will unfold over weeks and months and years. Jan Smit, a geologist at the Free University of Amsterdam who has spent decades studying the Cretaceous-Paleogene boundary, the geological layer that marks the exact moment of the extinction, describes the impact as the only event in Earth's history where a single moment in time is visible in the rock record, on every continent simultaneously. A thin layer of iridium, an element rare on Earth but common in asteroids, encircles the entire planet at exactly the same geological horizon. Every rock formation on Earth that spans this period has the same dark line, the same moment, everywhere at once. Above that line, no non-avian dinosaur fossil has ever been found. Below it, they are everywhere. The line is less than a centimeter thick. 66 million years of time, compressed into a stripe of dark clay you could cover with your thumb. What it represents is the end of 165 million years of dinosaur dominance. 165 million years. For context, the entire span of human existence, from the first anatomically modern Homo sapiens to this moment, is less than 400,000 years. The dinosaurs ruled this planet for 400 times longer than humans have existed, and they were ended in a morning. In the first minutes after the asteroid struck, most of them did not know it yet. The sky was strange. The ground had moved, and somewhere in the forests and swamps and plains of the Cretaceous Earth, animals that had never known a predator they could not outrun or outfight stood still and looked up and waited. They're still there in the rock, exactly where they fell, and the layer of iridium above them, that thin dark line, less than a centimeter thick, is the only monument they ever received.